This is the Gowanus Canal. It's located in Brooklyn, New York, just about a block from my apartment in Gowanus, and I pass it every day on the way to school and now on the way to work. The Gowanus Canal is a very special place in that it's both extremely polluted and yet extremely alive. Yet, at the same time, it's not special. I think that the Gowanus Canal really embodies where the rest of our built environment and our world as we know it has come to. Now, bear with me for a moment, but for me, our built environment and the world we are in is essentially a sponge with mushrooms growing out of it. By this, I mean that it's been so long that we've had these synthetic environments and these materials have embedded themselves into our world so deeply that what we call nature is synthesized with it and living together, sometimes for benefit, sometimes for worse. And we're finding that this blended world is what we live in and what we will live in. The Gowanus has a thick layer of sludge that we call black mayonnaise on the bottom for its consistency from the coal tar industry 60 years ago. It has downtown Brooklyn rising ever faster and making its way towards the canal for development. It has this history of industry, but it also has a neighborhood, and it has commuters and people that will recite Walt Whitman to them on their way to work. It has an army of volunteers for the Gowanus Canal Conservancy maintaining landscapes right next to active concrete production. It has a master plan that's proposing to bring back the lowlands that it once was in this exact sponge and mushroom way, where we will interact with the nature that we will seek to revive. And here in all of this, we have fish jumping at sunset and fledgling geese growing up right next to this same industry. Yet sometimes the sponge absorbs something that doesn't quite help the mushrooms. This is also the Gowanus Canal. And during small rain events, as much as half a centimeter, our sewage system in New York builds up from the stormwater and overflows into our waterways. And it's most easily seen in the Gowanus Canal. It's called the combined sewage overflow. And it's very, very evident. You can see here all of the street garbage, takeout containers, newspaper bags mixed with raw sewage. And all of the biology and chemistry, all of the medication is leaching into the water. We label all of this as waste, and it's very hard to do anything with waste but just get it out. But what if we saw this as asset? What if we could actually see it even monetarily as an asset? Would that enable us to clean it faster and even make use of it? This is the question that some waste was born out of. Some waste takes what we all know we consider to be our own waste in the most true form and turns it into functional products that we interact with in our everyday life to create a new relationship between what is dirty, what is clean, what is waste, and what is asset. So I set out to figure out what happens on a normal day where we don't have a combined sewage overflow, and it took me to the Newtown Creek Resource Recovery Facility. It's a pretty amazing place. These are 8 huge digester tanks that are each 80 meters tall, and they take in almost all of New York's sewage every day. What happens is, New Yorkers use their toilets and produce 1.3 billion gallons of sewage, enough to fill the Empire State Building 5 times. That sewage makes its way into the digester tanks where we anaerobically digest it, just like we do in our stomachs. We feed it to small organisms called methanogens, and they create methane, just like we do in our stomachs. We actually make natural gas from that methane, and we pump it back into our system for homes for heating and cooking. So already New Yorkers are cooking their next meal with all of New Yorkers' last meal. It's a pretty amazing sponge with some pretty obvious mushrooms growing out of it. And this residue that you see, this solid waste, this solid byproduct, is called biosolids. Now, for a long time, we didn't really know what to do with our biosolids. We were dumping it in the ocean. Finally, that became illegal, and we invented what we call the poop train. The poop train ran all the way to Lamar, Colorado, across half the country, where we would use that as an agricultural amendment to amend soils. It worked pretty well, and it cost a bit of CO2 to get it out there and a good amount of money, but this was a 100% beneficial use of our biosolids. Until 2008. When the economic recession hit in America, it became too costly to compost it, and landfills were willing to take other materials than they usually do because of lack of development and lack of garbage. So they started taking it for half the price it cost to compost it. Habits die hard, and it's been 10 years straight that we've been landfilling it every day. In New York City alone, we produce a lot of biosolids. It's 2.8 million pounds of it every day. That's enough to equal the weight of 100 school buses. If you started landfilling biosolids on Monday morning when you started your work week, this is what you'd be sitting under by Friday. The mayor's office in New York has made a promise to get all waste out of landfill by 2030. It's going to take an investment, and it's been so long since we've done anything but landfill our materials that we're going to have to invest in our waste treatment plants as well. The way we did it before, as I said, cost a lot of CO2, and we're exerting a lot of methane right now just putting it in landfill. So maybe we can use the material for something else that can keep it local, not transport it away, and even find a more beneficial use. These are bacteria, not in biosolids, but they do eat it. These are bacteria that produce a bioplastic called PHA. The white globules that you see inside them is actually a natural polyester. They feed on any natural feedstock, and I worked with a bioplastic startup using food waste to confirm that we can also feed them biosolids. And in fact, a lot of them really like the fatty acids and everything that we eat as well. We feed them and stress them, and they produce this in their cell walls, and then we can take that and make a bioplastic. What's most amazing about PHA is that it's soil compostable in as little as 60 days. That means that even if you don't have composting in your area, you can, if you put it in the soil, it'll still compost away. So why don't we close the loop? We can produce methane as we do as usual, but instead of sending our biosolids to landfill or even all the way to some other state to use it for agriculture, we can produce products in New York, made by New Yorkers, for New Yorkers, that are disposed of within the city. They make it back to the egg, back to the sponge, and support the mushrooms. So how do we apply this material in a way that makes sense to get society to interact with it in a very intimate way? It turns out, oddly enough, we're more intimate with our pens than we expect. We write notes on our hands, we chew on our pens while we're thinking, we put them behind our ears, we hold our hair up with them. We keep them close to us, and yet, at the same time, nobody really owns their pen. You sign receipts, you write checks, and they sort of disappear into the ether. They're almost like a weed that just grows around. We make a lot of pens, too. In 2005, when Bic made their 100 billionth pen, 55 years after they opened, they averaged 57 pens a second of non-stop production. This is 1 minute at that rate. And that's from when they opened, so it's only gotten higher from here. A lot of pen companies boast that they put more ink in their pens to make it sustainable. It accounts for the same amount as multiple pens. This ad shows that one ballpoint pen can write for 2 kilometers straight in a line, or 4 times the height of the Empire State Building. I don't know about you, but I've almost never seen a pen until it's fully dry. It just sort of wanders away. Even the pen itself is really difficult to recover if you do manage to keep it and then recycle it. The outer shell is usually made of a lower cost material of lower quality. And so if you do recycle it, it goes to a recovery plant, and we use ocular sensors to reflect back and see what plastic it is. If we only see the outside plastic, it's likely that it'll go to landfill, as it's difficult to recover these less expensive materials. And the cap, it's as good as gone the second you buy it. Retractable pens is a whole other mess. There's so many different parts, materials, manufacturing methods. And yes, you can replace this easily, the ink cartridge inside, but opening this up and putting it back together is a daunting task. So it seems that the pen design itself also needs a bit of a revamp. This is the Some Waste pen. This is what I designed in response to this research to simplify it and give new breath to the biosolids industry. It features 1 barrel made out of PHA, fully compostable, and 1 ink refill, standard with a small alteration on the top that is a complete technical nutrient. It's fully recyclable. And I also created a pigment made from biosolids itself that can be put into an ink. The spiral channel that's on the barrel is more than just aesthetic. It acts as a way to create friction in a mechanism. People buy the pen in 2 separate parts. One might last longer than the other, and you should know that one's compostable, one's recyclable. You put it together by sliding the ink refill right into the barrel chamber. As that polypropylene bends around the spiral, it creates friction. Just enough friction that you can retract the pen by tapping on the tip, but it still holds back enough for you to write, getting rid of all those extra materials, production methods, and mechanisms that are difficult to recover and make. The Some Waste pen is 1 inch shorter than normal pens, yet it holds the same amount of ink. If anybody knows why pens are this length, please tell me. I'm trying to figure it out. The ink itself can also be made of biosolids. It turns out that in my research, I learned that carbon black is a pigment used in almost everything that you find colored black, from this stage to the ink that you print with to your car tires. It's usually made by burning fossil fuels and collecting the soot. and then they suspend that in any medium for the right application. I set out to see how I could make this from biosolids, and I knew that what I needed to do was carbonize it into a pure carbon, just like carbon black. Rather than use energy creating this method, I decided to try and use the power of the sun. So I took an overhead projector and took out the Fresnel lens and focused it like a giant magnifying glass on a test sample. Though this is a small sample, it worked. You can see the center bullseye ring is all the carbonized material, and on the inside of the top, you can see how hot the sun was, burning in the inside of the metal where it wasn't even exposed. I ground that sample up, molded into a pigment with a natural oil, and stamped it on cards that I handed out at the first exhibit for this project. The cards were more than just a way to show the branding and show the way that this ink can be made. The pens were 3D printed, so it's a concept. And it's one thing to ask somebody to imagine holding a pen made out of digested sewage, but to actually ask you to put it in your wallet is a different story. So people walked away with a sample that they had themselves. I've ramped up production a bit as demand has grown higher and I'm looking for better solutions, and have hijacked a couple more home items to speed up the process. And I found a way now, working with a local letterpress in Gowanus, to get the pigment up into the printmaking method. We're working with a local poet who writes poetry about the Gowanus Canal, and we'll be publishing soon at a local shop. We're using a press from the 1800s that's still in use today to letterpress cards for some waste in Biosolids ink. In fact, if everybody's willing to lean forward a little bit, you can see a little white tab in the top of the chair in front of you. You have a card there for you that you can take home. What's really nice about this specific card is that the pigment that came from this is actually made from a new partnership that I found. It turns out there's a company out there that's made a machine that can dry and carbonize biosolids in a carbon negative way. They're using the heat of the actual bacteria and then the methane that they digest to carbonize it. So we now have a test site that's producing 1 ton of material a day, which means we have a material stream for this pigment to go into production. Really exciting. I think of this pen and the form of it and the use of it as a gateway product. People need to get used to this kind of a material. And like I said, pens are sort of accidentally intimate with us. The hope is that as you write a note on your hand to remember to do something later, or you're thinking about something you're working on and you start chewing on your pen, you realize that maybe this isn't as disgusting at all. Maybe even what we made pens out of is worse. And maybe starting this production and rethinking our industries can even help a canal in Brooklyn. Thank you.